So couple things. Let me say a couple things, and then I'll see if anybody has specific questions. So a couple things that are driving me a little crazy. Let's see. Oops. Whoop, whoop, whoop. So there's several things, but so if a problem said the mean has been 70, and then somewhere down the line it says we think the mean has decreased, the claim is not that, all right? That's not what we're claiming. That's what the mean has been. We're claiming this, and there's the giveaway language. Okay, so that's one little thing. There's some people that have just been putting mu equals for everything, and you got to find the language that talks about we feel, we think, we claim. You got to find that. That's the claim. All right, so that's one thing. Next thing. Several people, for some reason, so if this was mu less than 11, so this would be mu greater than 11, where is the tail going to be for the rejection region?
The left side.
Yeah, it'll be here, of course. Less than, that way. Several people are I think they're just always putting it here unless it's two tails. That's less than, the tail is there. And let that make sense. The only way I can show evidence for this guy is if my sample is below 11. So why would it be up there? It wouldn't make any sense. Okay. Let me think. What else was there? Most of you, thank God, are not using the worksheet in the book. Like I said, right? Their worksheet's crazy. You do the 5 steps like we did. Some of you guys haven't gotten that message through yet, but yeah, now you will when you redo the homework. Let me think. I can't think of. All right, so let's go to specific questions. You guys have any specific questions? Ouch. What if it's greater than? Oh, well, yeah. Yeah, then of course it'll be, so if H1 is mu greater than 2, then of course it'll be up here. That'll be the rejection region. You get the alpha and you get your Z. Over here, there'll be alpha. Jeff, you could do it. Alpha and you get your Z. It'll be negative from whatever Z is. Is that all right? The H1 sets up where your rejection region is going to be. Let that make mountains of sense. The only way I can show evidence that the mean is bigger is if my sample ends up here, above 2, not below 2. Doesn't make any sense, right? So that's an arrow that points you where the tail is. I like it. Okay, so any other specific or general questions?
I have a question.
Yeah.
So for the echo. So in the book, there's a specific, like the question, it says the high is equal to like 11, and then it says, oh wait, no, sorry. It says, okay, it says HO is equal to 11, and it says high is less than 12. So would the rejection region be on the left side?
Wait a minute. So which problem is that?
I can look. I can look.
All right, please do, because I don't believe what you're saying. Because that doesn't make sense. But remember I said the book does sometimes have the null hypothesis as equal to, when it really shouldn't be, because it's really not the opposite of what the high is. Remember, the hoe and the high have to be opposites from each other. But the book does sometimes have, like, the high will be greater than 2 and the null will be equal to 2. So that really doesn't make sense, but it's just the way that some stats people do it. Let me know if you find that problem. How's everybody else? You guys have any, you guys remember what's happening today?
Quiz.
Is on chapter 9. There's nothing on there about chapter 10. Right, it's just chapter 9.
I was, cause like I'm still kind of confused. Like I get the concept, but I get confused sometimes. Like, so before the last step, when we figure out if like the area falls into the rejection region or not. So when it doesn't, that's when we say we have found sufficient evidence. When it,
So in order to say we have found evidence, we have to actually get into the rejection region.
okay,
Yeah. So
so
we're always, the evidence we're trying to find is that the mean is somehow different,
mhm.
right? In order to do that, I've got to get so far away from the middle. So I will find, when I get into the rejection region, I have found evidence. When I don't, I have not found evidence.
And then the reject and support depends on the claim.
Claim. If
Okay.
it's the null, it's always reject or fail to reject. If it's the high, it's support or fail to support.
Okay, thank you.
You're welcome. And again, to be honest, I mean, you can just kind of memorize all this shit, but it all makes sense. It really does. So like, for example, real quick, if well, I'll do that one. Oh, I see. Okay, I'll get to that, Geneva. If I did my sample for this problem here and I got there, this guy believed it was outside of here. This guy thinks it's in here. I made it, I didn't make it far enough away to say he's wrong. I did not make it far enough away to say that I can reject this guy. So therefore I fail to reject this guy. I fail to support this guy. Everything goes together. So if I make it like out here, the guy who thought it should be in here is wrong. I can reject him then, because he thinks it's in here somewhere. Equal to, he includes the idea that it's equal to. So he thinks it's in here. This guy looks to be right. He's the one that thought it was greater than. So then I would succeed. I can reject this guy. I can support this guy. Okay, maybe. So it's more than just memorization. It actually makes physical sense. If you've drawn the picture, it makes physical sense why we say what we say. Okay, so I got the question from Geneva. Let me see. Let me move you guys over here. 95, number 49. Oh, okay. Then this is much more reasonable. All right. So again, what sets up the rejection region? Is it the null or the alternate? What sets up the rejection? I'm sorry.
The alternate.
Yeah. So who gives a shit what this says? Look at this guy. Is it directional? Is there direction inherent to that? What do I mean by that? Like, does that make sense by itself? Is there direction to the statement? Is there a left or a right? Oh shit, what just happened? Wee-haw. Where did I go? I love this. Oh, crappity, dude. Give me a second. All right, here we go. Uh-oh, where was it again? Jeez. Give me a second. Number 49. Okay. All right, let me ask this again, because I brought this up before. For 49 and 50 and 51, the HA, are they directional? So like 49, is there a direction implied?
Yes.
Yeah, less than, to the left, right? This one greater than, to the right. So this would be a left-tailed test. Because which tail would show evidence of less than 9? So the way we would draw this, oh shit, I gotta do this.
Bluetooth mode.
Is it connected?
Bluetooth connected.
Thank you. All right, so how would I draw this picture? Oh shit. Whoa, shit. Okay, there we go. Bam, bam. So here's what the null thinks, I think it's here. I think it's around 9. And the alternate thinks, I think it's less than 9. So that's a left tail test, less than 9. That's an arrow that points you in the direction of where the tail is. So that's going to be a right tail test. What kind of test is this going to be?
Two tails.
Oh, geez. Next in there. I love it. All right. So in fact, in the olden days, way back, like before TikTok even, we used to write not equal to like this. We used to write not equal to like this. Right? Math people, we really don't like multiple symbols in a row. So we stopped doing that. But you can see how that's more evident that it's two tails, less and greater. Anyway, I don't know if that was helpful to show you that, but not equal to will be a two-tail test because it could be up or down. Either way will show evidence. These guys are purely one direction. Only one direction will show evidence. How we doing out there? You guys all right? You guys all right? You guys hating life? No more than normal for this year? Okay. All right. Oh, here comes a chat. Sure, you're welcome. Anything else, guys? Anything else? Homework, specific, general questions, anything?
I kind of have, I don't know if it's a stupid question, but I kind of just had a question generally. So this is kind of going back to when we first started the class. For when we have like a set of data when we're given for a hypothesis test, when we're given like a sample standard deviation, would we have to divide it by the square root of n to make it?
Oh, were you? All right. We just had a discussion about this just now, earlier. And it might have been before everybody got here. I can't remember now. Sigma and S both mean the exact same thing. They just talk about different groups. They're both spreads of individual data. It's how spread out individual data is in a population or how spread out individual data is in a sample. When I take a sample and get a sample mean, now I'm curious how spread out are groups of that size from each other. Not just individuals, but how spread out are groups. So I don't care if it's sigma or S, you still have to divide by the square root of n because that's what makes it become a spread of groups, not a spread of individuals. So quite a few people made that mistake. You're dividing by S, but you're not talking about individuals. You're talking about groups. You have to change that by doing S divided by the square root of n. Does that make sense?
I think so.
All right, let me think. How else got to say this? I don't know how else to say that.
I don't know. I think I was one of the ones that made that mistake a lot, actually. So that's why I'm kind of getting a little bit confused.
All right, so let's do this because this is a generally difficult thing to understand. I understand. I understand how you might not understand. Okay. So everybody do this for me real quick. Throw these in your calculator and figure out the standard deviation. I'll do it with you. So go to stat, edit, throw it in the list, do one var stats, all that kind of beautiful stuff. This is I'm not, I don't know. I won't say anything. Did I say, I didn't say what this was, did I? This is going to be very interesting. Can you tell me what the standard deviation is? I don't think I've given you enough information to tell me what the standard deviation is.
4.031.
Somebody thinks I have. I like that. What did I not tell you that I need to tell you before you can tell me what the answer is?
Is it
It's
normal?
normally distributed.
Nope, I don't care about that. I can always get standard deviation. It doesn't have to be normal for me to just get a standard deviation.
What type of standard deviation? Sample or population?
Yeah, I didn't tell you this is a sample or a population. So let's see, if it's a population, then it's what Hiroshi said, I think, 4.031. If it's a sample, then it would be this one, which was 4.65.
650.
Do it, Jeff. And do you see, this is so beautiful. Do you see how the calculator tells you that's SX and that's sigma X? Do you see how they're not bars yet, like they're supposed to be for hypothesis tests? So I don't give a shit which one you get. You have to change it to the one that works for sample means of groups. You have to divide by the square root, in this case, of 4. Because this tells me how spread out these are from their middle. This one tells me how spread out every group of 4's mean is from each other. This one makes it a spread of groups. This one is a spread of individuals. That's what X means, right? Individual data values. What does X bar mean? An average of a group. Does that make any more sense?
Yes.
Good. So I don't care which standard deviation you're given or that you calculate, you have to change it into one that works for all groups of size, whatever, right? You have to do the divided by square root of n. I like it. I like it. Okay. Is that better? Heidi, I think you're the one that asked me the question. Is that better or is that not good enough? I can handle it if it's not good enough. Just be honest.
No, that makes more sense. Thank you.
Okay. You're welcome. All right. Okay. And some of you guys are just not drawing your picture correctly, not putting, you're kind of making the work harder on yourself because you're not slowing down and just putting the numbers in the right place. How do I mean by that? I've had people do this. Here's their rejection region, right? And then they put here, they put this negative 2.6, and they'll say negative 2.6 is less than negative 2.71. No, it isn't. No, it isn't, right? Right? I mean, are you guys kind of with me? I mean, that doesn't go there. It should be over here. It didn't get more negative than this one did, right? I guess. Okay, so there are really conceptual errors. There are little errors like this that I don't think you believe that that's true, but you're just so immersed in all the other shit, you kind of like miss something like that. I understand that. Does anyone have anything else? Does anyone have a specific problem they want to look at, or?
I don't have a specific question. Not, yeah, I don't have a specific problem, but the question, so when you finally get finished with everything and you have to write your conclusion, when you're looking at it, you look at the claim to figure out which one to use for the conclusion, correct?
Yes.
Okay, so if the claim was your null hypothesis, you use the wording for the null hypothesis, or
So that'll be reject or fail to reject. Yes.
okay.
Good. That's all you can ever do with the null hypothesis is reject it or fail to reject it. And the only thing you do with the alternate hypothesis is support it or fail to support it. Okay. All right. You guys all right? I mean, right now you could say, man, I had a lot of trouble with this. Can you do this problem for me, Jeff? That would be an acceptable thing to ask right now. Otherwise, we're just going to keep on going.
Mr. Waller,
Yes.
for number 74 on the 9.5 homework,
Yes. That evil problem.
I don't remember if we did it last time, but you said we have to consider it normal, right?
Yeah, I still want you to do the problem because you're supposed to be getting practice, but it's not a bad idea in step B, in the second step, where you're supposed to show that it's normal enough. You say, this actually is not normal enough, but it's pretty close to 30, right?
Yeah, it was close to 30.
Technically, I was okay if somebody did not do number 74 and they said, not normal, we can't do it, as long as they did every other problem in the book, because 74 is the only one that isn't covered by this statement here. Kabam, kabam, kabam. So I think it's just a mistake on their part. They should have said the distribution, the population is normal or something. They should have said something. 28's not good enough. But, you know, so if you didn't do number 74 but you did every other one, you're fine. But some people didn't do 74 and they didn't do several other ones. But this one right here says, hey, it's normal if you're going to use a t-score, right? So 74 is the only one I could see somebody saying, can't do that, Jeff. And I kind of like that. I kind of like that. Is that all right? Maybe. Because I mean, it would be so evil for me to put on a test a problem where if you don't notice it's not normal, you waste all this time doing it. Can you imagine that? Can you imagine that? And people are like, oh, your test was so long. I'm like, no, it wasn't. You didn't have to do that problem. Oh my God. Then you would be allowed to find where I live, knock on my door, and then kick my shins. Right? Come here, Jeff. Bam. All right. You guys doing okay out there? Oh, it's just, all right. So let me tell you this. The formulas are on the quiz and it's just hypothesis tests, right? It's just chapter 9. So that's what you got to know is hypothesis tests. So make sure you got your T and your Z-score chart ready. Is that all right? Is that good enough? Let me see. Have I completely demoralized all of you? That's pretty good. That's pretty effective of me. Are you guys all right? Is anybody out there? If you can, turn your camera on. If you don't want to, okay. Just remind you guys, the final, you're going to have to turn your camera on. So if you need help with how to get that accomplished, you got to let me know. All right. So we're gonna move on.
For the final, are you gonna give us like a study guide?
Yeah, I'm
Type
gonna do a
thing?
practice final with an answer key. Yeah. So that'll be a part of what we review on that Monday, that last Monday, the last day of class. So nobody has a problem specifically they want me to look at? Okay, all right. So let's see. So we left off in chapter 12, talking about correlation stuff, right? Let me see. I really don't believe you guys that nobody has any more specific questions, but I can't make you ask them, so I'm going to keep going. Let's see. So what I want to do is do another example problem with you in the calculator for chapter 12. And then we're going to do a little bit more than we did last time. Let's see. Let me look up a problem here real quick. Okay. Whoa. Let's do this. There we go. Yeah, all right. That's not very interesting. Yeah, let's look at, well, this might be all right. Well, that's not good. Get out of there. Oh, here's a good one. Okay, let's do this. So this is, I have no idea what page this is. This is number 68 in the chapter 12 homework. So unfortunately, we've taken a hit on life expectancy probably, and it also doesn't show this, but remember, does anyone remember what happened 2006 to 2008? So many guys were probably 6 or 8 years old, but
Are you
go ahead.
talking about the recession?
Yeah, big old recession. So actually we saw life expectancy go down a bit in there. Well, somebody's calling me. Am I jumping all over the place? I love it. So, oh, by the way, if you were not here last time, you are definitely, oh shit, sorry everybody. Oh shit, now I'm going to show everybody grades. How can I do this effectively? Get out of there. So if you go to Canvas, to our shell, and you go to modules, and you go down to unit 12, you'll see this bad boy. So yesterday we talked about drinking beer and taking tests and all that kind of stuff. Not yesterday, you know what I mean. And we actually did both of these examples in the calculator. So chapter 12 is one place where I do allow for most of the work to occur in the calculator. And actually, let me show you this just to really freak you the shit out. Let me show you this here. Where would it be? Let me see if I can find it real quick. I want to show you the formula for our R. It's going to probably be here. Let me see if can I find it at all? Where are you? All right, someday I'll find it. Where are you, R? All right, I'm not going to find it. So anyway, the formula is remarkably large. It's kind of remarkably gross. I can't believe I can't find. Here it is. Okay, here it is. Just gaze at the beauty of that thing. I mean, look at this weirdness. Does anything in there look familiar at all?
No.
All right, it's the wrong answer. What
Kind.
about this little? Look at this piece. Not the
Isn't
whole
it
thing.
We just learned or no?
Say again, sorry.
Isn't it kind of like what we just learned, except it would be like, I don't know. It looks like a little different.
It's like not much we've ever learned, to be honest. But do you see right here, sum of X? Haven't we seen sum of X before? Right there, sum of X. Remember good old sum of X? And there's sum of Y. Why is there an X and a Y? Because this is all about two variables, right? Like beers and test grades, the X's and Y's, right? Down here, to be honest, these two on the bottom, they're not written in the same format, but these are the formulas for standard deviation. They're just kind of reworked a bit. And it's kind of beautiful because R is sort of like a two-dimensional standard deviation. And sure enough, it's got the standard deviation of the X's and the standard deviation of the Y's in it. So if you missed the last class, you missed quite a lot, right? We talked about what R tells you. What does R tell you? What would R equal to 0 mean? Can somebody tell me? What would R equal to 0 mean?
No correlation.
No linear correlation. I like it. Can somebody else tell me what would R equal to -1 mean?
A perfect negative correlation?
Sweet. So that means that all the data points would perfectly line up on a negative slope line. I love it. And of course, +1 just means same thing, but with a positive slope line. So most everything we analyze will be between -1 and 1 and not equal to -1 and 1. That's perfect. That hardly ever happens. The closer it is to 1 or -1, the stronger the relationship is. Okay. So what do I mean by relationship? Let's see, if we look at this, this is the stuff we talked about last time. This is definitely stronger relationship than this is, but they both have a negative correlation. They generally trend down. This is stronger than this one, but they both have a positive relationship. So this R will be less than this R, or further, or let's see, closer to 0. This R would be closer to 0 than this one. This R will be closer to 1 than this would be, right? Is everybody with me? The people that were here last time when we talked about this, you must be with me because we already talked about this idea. There is a very specific point. Well, let me be careful. There is a place, there's a value of R that if I make it past that value, that's evidence that there is a correlation. So let me do this. Pop. And I'm going to tell you this value. And I, of course, forgot to find the chart, but oh, well, I'll find it. So if I tell you, it's dependent on the sample size. So if I tell you, if I give you a problem and I give you all these data points and you put them in the calculator, and I'm going to tell you R must be greater than 0.456 to show correlation. Are you guys with me? It is exactly like a hypothesis test. In fact, if I really felt evil, I could make this section 12 be about hypothesis tests for correlation. I decided not to be that evil, right? Just to see what it felt like. So if I do this work and I get an R equal to 0.5, is that evidence of correlation?
No. Or like
What
not
is
enough.
0.5?
Yeah,
Yes.
definitely.
It's definitely evidence of correlation. Would you say it's strong or weak?
Weak.
Weak. Good. So this would be weak positive correlation. What about if R was 0.41? What do you guys think? Is there evidence for correlation?
No.
No. So no correlation. Or you could say, if I was being really evil, I would make you say, we have not found sufficient evidence to say that there's evidence of correlation. Or something. What if R was 0.93? What would you say?
Strong positive correlation.
Yes, there's correlation because it's bigger than this, and it's strong because it's closer to 1. Strong positive correlation. Blah, 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 blah. So again, the closer, if it was exactly R equals 1, they would perfectly line up. The minute I start taking some of these points off the line, I start going less than 1. If I get a lot of points that are very far from the line, now I'm getting closer to 0. So R is a measure of how well the points line up, is really what R is. And the fact if it's negative or positive just says, is the way they're lining up following a negative slope or a positive slope, right? How you guys doing out there? You guys okay? Relatively? Not even relatively okay? Everything sucks. Okay, all right. So let's try one of these out. I have like no room in here. Okay. So let's take a look at this problem. Oops. Oh shit, where are you? There you are. Let me find this problem again. Where'd you go? Oh yeah, that's right. Gotta go back here. This one about life expectancy. Where did you go? Here it is. Now, let me see. Well, let's just do this. We'll just do it. Yeah. Everybody take a minute and put this data into list 1 and list 2. Right, so you get your stat button, edit, put this data into list 1 and list 2. All right, let's see. All right, thank God. It's always nice when the columns match up. Oh, why am I doing it on my, that's hilarious, Jeff. That's all right. I'll survive. I'm doing it on my real calculator. Oh, come on with this. Why won't you let me? All right. Has everybody got those numbers in your calculator? Anybody not got those?
Like one more second.
Okay. All right. I'm going to stop sharing. Here we go. Oh, let's see if anybody yells at me. Okay. So here's what it looks like. Ooh, look at that. That's funky looking. Right. So it's all in there in the lists. And thank God the lists are the same size. That always sucks when you get to the bottom. Where am I? There I am. You get to the bottom of the list and it's not the same size. Oh, that so desperately sucks. So who remembers what to do now? What do I push to do this?
Stat and number 4.
Stat.
Oh, I'm sorry. Stat, calc.
Calc, I like it. So we're in this. Hold on. Dadgummit. All right, so we're in that list there. Stat, calc. And then you're right. The fourth one, see how it's got an equation of a line? So we want to try to find the line of best fit. Stat calc number 4. All right. Then you get to a, this kind of sucks, Jeff. Oh, well, I'll just keep going. See what happens. Then you get to this stuff here, right? So you want to make sure, you want to tell it, oh yeah, calculator, my X's are in L1, my Y's are in L2. Oh shit, let me make sure I can do the right thing. And then you go down to calculate. Calculate. Oh, look at that. That's hilarious. What am I missing? Does anyone else's look like mine?
No.
What do you guys got? You got more, or did you guys get those numbers?
I have R and R squared.
But the other numbers are okay?
Yes.
A, B? Okay.
Yes.
Is anyone else missing R and R? Is anyone else only got what I got? Everybody else is good? All right, let me catch up to you guys. My poor little calculator. Poor little dude. There we go. All right, now this should really match up with what you guys got, yes?
Yes.
I like it. So right there already, can you tell me if this is this a good correlation? Is this a strong correlation?
Yes.
What do you think? Yeah. I mean, I haven't told you what the R is to show evidence of correlation, but I mean, this is freaking 0.96. Hello. Right? That's damn good.
Your camera is blurry.
I know. It's because I'm using, I'm going to transfer this into my my calculator on the computer, so I don't have to keep going back and forth like that. So you guys take a minute, see if you can remember how to get the scatter plot and the line of best fit to show up, and I'll slowly catch up to you. Whoops. There we go. So of course, to make sure that your calculator finds the data, what do you have to hit? Zoom what?
Zoom stat.
Zoom stat. And then of course you have to remember where to put your line of best fit so it'll show up. It's a really weird sound. What is that? Let's see. Yay. All right, so let me share this. This is much better. There we go. Much better. All right, so there's the same stuff, thankfully. So there's my line of best fit. So like 0.23x minus 377.24. So let me put that in here. I already forgot what it was. Good job, buddy. Really, 0.23 x minus 377.24. I think that's what it was, right? And if I just hit graph, it looks really sucky. But of course, like you just told me, if I hit zoom 9, why does that not look right? Poor little dude. Did I put this in here wrong?
It was 0.227.
Oh, 227. What am I doing, Jeff? Oh, wait. Well, that's basically the same thing. So why does it look
Plus
so bad?
negative 377.
Negative 377. Yeah, negative 377. Let me see. 227. Looks fine. Let me do one thing for myself. Turn this back into a box, little square. Yeah, see, now I can tell something is very wrong. Do you see that? That just
Mine's like
isn't
that too.
lining up. So what is happening? Why is that?
Plus, it looked like you did minus 377 instead of plus negative 377.
But that's the same thing.
Oh, it shows, okay, because it's showing up differently in my calculator, and my line is a lot closer to the plots.
You see if this is that big of a deal here. Wow, it is that big of a deal. Okay, so we don't want to round that much on the slope. And just to remind you guys, you can always do this. When you do this calculation, when you do this, I showed you this last time, you can actually store the equation. So if you go to variables, y variable function, you can store the equation in y1, so you don't actually have to put it in by hand. So now if I just go zoom 9, there it is, and it looks pretty good. So that's a quick little reminder of not to round too much. But now it's like really not rounded at all. Holy crap, look at all that. All right. Is everybody all right out there? You guys all right? Okay. And so you can see this guy is kind of really far away, but it's balanced out by these guys. So it is trying to minimize the distance the line is from all the data points. That's how the math calculates that line. It tries to put it so that it minimizes how far away all the dots are from all the data points are from the line. Now here's something I don't think we did last time. So let me show you this again. So that equation, let me do it this way. This equation, 0.227x minus 377, blah, 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 is now, how much do I trust that line of best fit to make predictions? Will I trust that line to make predictions? and why? Was it a good fit? Was it a good correlation? Was it a strong correlation?
Strong correlation.
Strong correlation, exactly. So I am going to trust that line of best fit, right? So I could make predictions. So let's go back to the book real quick. So let me see if they ask you anything about that. Yeah, they do. I like it. They actually ask you a ton of questions. Crazy. But right here, they say, find the estimated life expectancy for somebody born in 1950. So, I mean, this is the actual life expectancy. They want me to find the estimated from my line of best fit. So if you wanted to see what it looks like by hand, I'm not going to do it by hand though, but it would be 0.227 times something minus 377.24, right? So what would go right here for this first one? What would go right there? What are my X values?
1950?
Yeah, 1950. My X values are year born, right? So go ahead. What is that? Go ahead and plug the old calculator, see what you get. All right. Has anybody got that yet?
65.41.
Yeah. And it wasn't, does that agree with what it really is? No, because this is just an estimate. Right, comes from our line of best fit, which doesn't match all of the data points exactly. It's off. Some of them it's off by more than others, but overall it's a pretty good fit. So if I want to show you a shortcut of how to get that answer. Let me see. Let me do two things here. Let me make my y equals match up with what more yours is probably. So probably mostly put 0.227 x minus 377.24, right? Okay, so let me see what this looks like. All right. So if I want to estimate for 1950, here's what I could do. Do you see right above trace where it says calc? So everything up here in this row is all about something graphical. So if I go second trace, I can then calculate stuff to do with my graph that I've made. I want to calculate a value. I want to calculate the value when X is 1950. And there's my 65.41. Maybe.
Can you do that again, please?
Sure. So go to second trace to go to calc. I want to calculate something graphically. I want to calculate something graphically. I want to calculate a value graphically. I want to calculate the value I get when I make X 1950. Now, in this specific problem, the more this is rounded, the worse the line is, right? So if I, now just stay with, is everybody cool with that little thing? Do you have to do it this way? No, of course you don't. Didn't we get this answer without doing this? Yeah, we did. We just plugged it in the formula. Who cares? If I do this way, where I put the whole damn thing and I go to variables, y variables, function, y1. Now when I do this, it will be much closer to real life. Well, not much closer, but a little bit better. 66.34. That's better. Because what was the actual answer for 1950? Let's go take a look. Bop, bop. 70.2 is the actual for 1950. All right, but again, the line of best fit, its job is not to be perfect for every data point. Its job is to be as close as it can to every data point, which means it's going to be further away from some data points. Let's try 1940 real quick. So 1940 is supposed to be 62.9. So let me share this. So if I try 1940, I'm going to do second trace to get to calc, calculate a value, calculate what it is for 1940. 64, there you go. Not too far off. What about 1972, Jeff? That's when I was born. 1972. I'm gonna die. It's when I'm 71. And of course, this is just an average. Here's something for you. Does anybody remember what median is? Does anyone remember what median is? Say again, sorry.
The middle.
Yes. It's the data point that has half above and below. The median life expectancy is always roughly 3 years more than the average life expectancy. Now, let me say that again. The median life expectancy. They've done tests and they figured out that it's always about 3 years more than the average life expectancy. Why would the average life expectancy be lower than the median? Because unfortunately, some people do die very young. Won't that bring the average down? The median wouldn't be affected by extreme values like that. So like that means for somebody born in 1972, half of us born in 1972 will live to be 74 or older. Okay, maybe. Somebody want to give me their date of birth? What year were you guys born? Somebody? Anybody? Oh, I got some chats coming in. 2000 and 2001. So let's see, 2000, your life expectancy is 77.7. So you add 3 to that, and then you have like half of the people will live beyond 80 who are born in the year 2000. 2001, just a little bit extra. You're eked out a little bit. I like it. And just to show you something I didn't show you last time. Do you remember I talked about these possibilities down here? So if I do like, let's do a cubic regression. Watch this shit. Let me store this because this is going to get freaky. And let's see. So there, see, it's a cubic, right? And now watch this. Let's see if we graph this. Woo-ha! Now it's all curvy. You can follow it. Now it kind of matches the data better. Anyway, all right. Something else to realize is this is based on a very small sample. So we can't really take to heart what this is saying too much. Okay. So chapter 12, let me show you something, how they broke this out in the book for the homework. The first section of chapter 12 is just a review of MX plus B. But of course, they're using the A and the B that stats people love to use for some reason. So section 12.1 is just a purely algebra section. It's just the algebra of lines. It's crazy. Y-intercepts and all that kind of stuff. 12.2 is just about plotting points. And then 12.3 is finally where you start doing some stuff with line of best fit. I do want to say, I want to show you this. What is this updates available? Oh, I'm gonna have to do that eventually. Let me show you something in the homework that gets a little freaky. Let's see. Here we go. So when they say, is it significant? Treat that as if they're asking, is it weak or strong? Is it negative or positive? Do you guys understand? I'm not going to make you do a full hypothesis test for that. Let's see. Is there anything else I wanted to show you? I think that's it. Yeah. Okay. I don't think there's anything too weird in here. And 12, let's see, is it 12.6? No. Where was it? Oh, 12.5. 12.5 is where they say use the equation to predict values, like we just did for somebody born in 2000 and 2001. So 12.5 is all about plugging values into the equation. Okay. So that's not too bad. Not too bad. Now, what I'm going to do now is I'm going to go back and I'm going to ask a question for everybody. Because again, I really think that you guys, we have that quiz today. It's on hypothesis tests. And I think that you would probably benefit by doing a few more examples of that. Does anyone have a question about correlation, about chapter 12? I mean, I kind of hope chapter 12 is sort of a breath of fresh air. Like after doing the crazy hypothesis tests, this should be relatively straightforward for chapter 12. Does anyone agree or disagree?
Yes.
Okay. All right. So let's do this. Let's do, we see nobody had anything specific, which I find really hard to believe, but could be true. For section 9.5.
Actually, I have a question now that I'm looking at it graded.
Sure.
For number 101, can you just help me identify, no, I'm sorry, for the conclusion, can you just help me word that out real quick?
All right. So here comes a big Christmas present. Let's just go ahead and do 101.
Okay.
Here we go. So there's number 101 right there. I like your desk going back. I think that's your desk going like boop, 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 boop. So read through this real quick. All right. Copy that down if you don't have the book with you. And here, let's do something we haven't done in a while. Has everybody got the 101? If you don't have a book, have you got that copied down? Some of you guys have already done 101. So, you know, you're like, dude, I've already done this thing. All right. So I'm going to stop sharing. I'm going to assume everybody's got that bad boy. And we're going to use a breakout room. Yeah. I want you guys, if you've already done this problem, maybe hang back a little bit, especially if you got it right. let's see. This way I can see who's really here. I always have people left over when I make breakout rooms, or sometimes I do. Let's see, here we go. All right, so just take a minute, a couple minutes to get this thing started, number 101. And then I'll pull you guys back in and we'll do it together up on the board. All right, here we go. Let's see, go ahead, go to your room. Help each other out. All right. People are here. Oh, somebody left. They're like, I'm not going to do that shit. Let's see who's not here. Is anybody not here? Yeah. Ian, Alexis, are you out there? Of course, you're both in the same room. That's kind of funny. Oh, geez. All right. Well. Oh.
Sorry, I was in the other room. I was grabbing something.
All right. Do you see what I'm pointing you to? Do you know which problem we're doing? All right. I guess so. Back. All right. All right. It's always a trip. Anytime you got something else going on, just let me know in chat or something. Just let me know. It turned out that there were a couple people that had things going on, and there was only 3 people in the room. So the third person sitting there like, what's going on? So you got to let me know. And at the very least, talk to each other about how much you hate this stuff or whatever. At least interact with each other in some way. But several rooms were working on the problem. I like it. So let's take a look at this thing. All right, Jeff. So it says the mean age was 26.6. An instructor thinks the mean age is older than 26.6. So the claim is older than 26.6. So of course, which one is that going to be?
The high.
Yeah, because there's no equal sign in it. And then this one, I would write this. The book might write equal to here, but you know, the book can be as wrong as it wants to be. How many tail tests will this be?
One
tail test. I like it because it's a directional symbol. It's going to be a 1 tail test up there because it's greater than. To show evidence for that, I have to be up above 26.6 by far enough. Do we use Z or T? Zort. Say again, sorry. T-score? Yes. Why do we use the T-score?
Because the population standard deviation is unknown.
Good. Sigma is unknown. What else?
It's normal.
Remember this section? Yeah, second, sorry.
N equals 56.
Yeah. Which tells me it's normal enough. That's probably the most important thing. And then this guy tells me which thing to use. This guy tells me, can you do anything at all? Now remember this section, if they don't tell you a value for alpha, you use 0.05. What's the degrees of freedom?
55.
55, I like it. That might not be on your chart, I can't remember. And it's a one-tailed test. Oops. So what do you guys get for the T-score for that?
1.676.
What degrees of freedom did you have to use?
54.
54.
55, sorry.
Oh, they do have 55 on there. Good. Okay, I forgot. I didn't know why they started going by tens.
Nah, I use degrees of freedom of 50 because 55 is not on there.
Is that what you get there?
Yeah, that's what I got.
Okay, I like it. So if they don't have the degrees of freedom you need, you pretty much always go to the next one down from there. Make your T-score a little higher to cover you for not knowing that. And, you know, it's not your fault. So if I want to put this into words like I'm supposed to, if T star is bigger than 1.676, we reject the null, support the high. All right, I like it. So we have a claim, we put it in the correct place, and then I forget about the claim. This is the guy that no matter what the hell this is, it's going to tell me where the rejection region is. Greater than, it means it's up there. That's where my sample has to show up to show evidence for this. Right? This step just tells me, can I do stuff and what can I do? Yes, you can use T-scores. All right. I like it. This tells me what is enough evidence. I have to get a sample further than this to get evidence that it's not 26.6, it's actually greater than. So then step D is, how much evidence did we get? So let's see, what do I know from the sample? I know it's X bar is what?
29.4.
Yeah, I like it, yep. And then what's S?
2.1.
2.1, so I've got to change that. N was 56, so what's S sub X bar? 2.1. Oh, I'm sorry, yeah. Divided by the square root of 56, what do you get?
0.281.
281. Let's see, that sounds about right. Yeah, that sounds about right. Okay. Everybody okay out there?
Yeah.
So if you really understand the idea behind each step, step one is just, what the hell are you talking about? Step two is, are you allowed to talk about it? And what are you going to use to talk about it? Step three is, what do I need? What's my benchmark? What's going to show enough evidence? What's far enough away? And then step four is, okay, then I know what far enough away is. Did I make it far enough away? So then I do it's always, some of you guys are getting this backwards. It's always our data minus this number. See how far away they are, divided by the new spread. Become an 8. So what do you guys get for that?
9.96.
Yeah, dude. I'm sorry. Didn't mean to yell at loud. 9.9 something or other. Yeah. That's insane. I mean, that's crazy big. Are you guys with me? We should know by this point. Almost 10 standard deviations above the, holy crap. This thing completely shattered this test, right? Is it in the rejection region? It is deep in the rejection region. It's way over there. Holy crap. So the guy who thinks it's here, which is this guy thinks it's here. Is he full of shit? How can we say he's wrong?
Yeah.
Yeah, so see, so each step does make sense. It's not just something to memorize. We totally demolish this. The person who thinks it's in here, which is always this guy, we can reject that guy. He's obviously wrong, or there's really crazy strong evidence that he's wrong. So we can support the high. Which one was the claim? Was the claim the ho or the high?
The high.
Yeah, the claim was the high. So then I would use this language. We have found sufficient evidence to support the claim that the mean, I forgot what it was, age of students at De Anza College is greater than 26.6 years. Right, so when you get to this point, you should know if you rejected the null or failed to reject the null. So you write those both down real quick. Reject the null, support the high. Then you use the language that relates to which one was the claim. That's it. That's it. I know once you see all the steps in one big thing, it looks insane. But each step, this is old. We've done this before. This step, we've done this kind of thing before, but it's, you know, we know what it's for. This step is old, calculating a z-star, a z-score, a t-score. But then the next thing we do is we see, where does it fall? Is it evidence or is it not evidence? It's kind of like when you get all 5 steps up here, it's like, holy crap, it's a lot. But each step needs to make its own sense. Oh, sorry. Oh, go ahead. Sorry. Let's see. Do what you got to do. All right. Is that all right? Any questions on that? Did somebody need to write that conclusion down? I just didn't have room. We have found sufficient evidence to support the claim that the mean age of these students is more than this. Okay. All right.
Can you pull up 78?
Yeah, let me see. Some of these questions are crazy. Here we go, 78. So what's up here? Oh, this is the one where they give you the list. All right. So you're obviously, so what's the question there?
We're using a t-score, right?
Totally, because the standard
Okay.
deviation you're going to calculate is going to come from the sample. I like it.
Okay.
And it's only 8, but remember that thing where they said, you know, t-score problems are normally distributed. So
So what does that mean then? What would the t-score be?
oh, the fact that we know it's normal just tells me I can do something. And then the fact that it's a sample standard deviation I'll have tells me a t-score. So then my degrees of freedom is 7, right? Because the n is 8.
Okay. Then
What's alpha? They don't tell me what alpha is. So what do I assume alpha to be?
0.05, right?
Good, good. And I don't know how many tail tests will this be. Let's see. Yeah, it looks like the claim is believed to be about 10. So that's an equal is 10, it says down here. So that's going to be a 2-tail test. Is that all right? How do I make that stop? There we go. You guys okay out there? Anybody? All right. Okay. So I'm going to say that's enough for today. If anybody needs to hang out after, ask me anything, let me know. Otherwise, you're free to go. And the quiz should be, I think the quiz should be active right now if you wanted to start on it now. Let me double check. Anybody have any questions they need to go over with me? Or are you guys good? You can head out if you're good.
Will you ever ask like a question on like why we go down for the degrees of freedom when it's not exact?
Yeah, because so in general, when you don't know something, you have to kind of, this sounds weird. I've said it before, but you have to kind of penalize yourself. So why do T-scores even exist? They penalize us for not knowing the real standard deviation. The T-scores are bigger. So it makes our errors bigger, makes the tests harder to pass in the hypothesis tests, right? So go ahead.
So pretty much they penalize us because because you know how usually you say like if we don't know much information we make the sample size bigger to like know more.
Oh, I mean, so if you have that option, then of course you would do something like that. But for us, we can't add on to the sample because these aren't even, we can't even talk to the people that are putting samples together, right?
Yes.
So what we do then, the reason that we have to use the next T-score down, if we don't know, you know, if our degrees of freedom we need aren't on the chart, is simply to penalize us for not knowing that.
Okay.
We make the T-score bigger so it can do its job. Its job is always to cover our ass for things we don't know. So the less we know, the bigger it gets.
Okay. Thank you.
Yeah, if we did this in a calculator, we know exactly the exact T-score to use, but that's, you know, who cares? How's everybody else? You guys all right? If you're really out there. All right, I'm gonna head out. I don't see anybody with questions, so good luck on the quiz. I'll see you guys next week.